Let us do a quick recap of whatever we have discussed until now, and post which we can proceed with the regular concepts. We have discussed about graphical representation. As part of that, we have discussed box plot. Box plot will help you identify what is the minimum value, the first quartile, which is also called as Q1, and this contains 25% of data. From minimum value until the first quartile, you have lower 25% of data. And then you have the third quartile, which is also called as upper quartile or Q3. From minimum value until here, you'll have 75% of data. And then you have the interquartile range, which is given using Q3 minus Q1. And this would contain middle 50% of data. And you'll have the maximum value, outliers, and median. Median is sometimes also called as Q2. And you'll have the lower whisker and the upper whisker. Lower whisker has lower 25% of data, and your upper whisker has upper 25% of data. So 100% of data can be represented using box plot, and box plot will also help you identify the distribution of the data. It is not just histogram, but box plot also will help you identify the distribution of the data on whether the representation is skewed or do you have any kurtosis, so on and so forth. And how are the outliers calculated? Toward the lower side, the formula is Q1 minus 1.5 times of interquartile range. And on the upper side, it is Q3 plus 1.5 times of interquartile range. Also, when we have discussed about standardizing the data, we have discussed about the Z distribution, X minus mu as sigma, which would standardize the data. But when it comes to your R programming, the function that has to be used to standardize the data is scale. That's the function you need to use, right? For example, say I have work experience or GMAT and I want to standardize that. One way is to manually do that, but we would never manually do that, right? So I would say standardized GMAT value. Just need to use this function called scale. Scale of MBA $GMAT. Why MBA $GMAT? Because I have this variable called GMAT in this dataset called MBA. There we go. If I click on this here, it will show you the standardized values. In that way, you can also standardize the entire dataset. Rather than standardizing each column, you can standardize multiple columns at one go. All these things slowly we'll be building upon. And we have also discussed about normal distribution. Yeah, what is a normal distribution? It is a bell-shaped curve. It is symmetrical across the mean equal to median equal to mode. And you have the three empirical values, plus minus 1 sigma, 68%. Of the values would meet your customer requirements, right? Plus minus 2 sigma if you can fit in 2 standard deviations on either side. 95% of the products or services would meet the customer requirements, and if it is plus minus 3 sigma, then you'll have 99.73% of products or services which meet the customer requirements. And each data, each variable would have a different mean and different standard deviation. Can I have a standard average and standard deviation, which would make the standardization process very simple? That is when we have discussed about standard normal distribution, and standard normal distribution is also called a z distribution basically, and this is the formula: z equal to x minus mu by sigma. And when it comes to our programming, you use a function scale. Standardization is also called as normalization, and standardization or normalization would essentially make the data unitless. So we have discussed all that. And we also know that probability associated with a single value is always zero. And we have learned about another property called area under the curve, which is always equal to 1. And post which we have also discussed about the central limit theorem, which says that if the population is normal, your sample mean would also follow normal distribution. However, if your population does not follow normal distribution, your sample mean would still follow normal distribution, provided the sample size is large. What do you mean by that? Sample size should be equal to 30, that's the thumb rule. And for these 30 data points, calculate the skewness. And n value should be greater than 10 times of skewness square. Or n value should be greater than 10 times of modulus of kurtosis. This is all that we have discussed until now. Now let us proceed discussing about the various other concepts. Let us now discuss about confidence interval. What is confidence interval and in what scenario would you use that? Here is a question. What is the probability of tomorrow's temperature being 42 degrees? What do you think? Probability associated with any single value is always 0. Right, probability associated with any single value is always 0. You need to remember this. Hence, you cannot come up with a point estimate. If there is a single value, then it is called as point estimate. We cannot come up with a point estimate. Instead, you need to come up with a range. This range is called as interval estimate. This range is called as interval estimate. And can it be minus 50 degrees Celsius to 100 degrees Celsius? So if probability associated with a single value is 0, right? Then can I give you a range, that is minimum temperature and maximum temperature. Most news channels, or if not all news channels and all the newspapers, provide the weather forecast in this way: minimum value and the maximum value. If probability associated with a single value is 0, then can we come up with a range which is so wide, minus 50 degrees Celsius to 100 degrees Celsius? Absolutely no. You would just laugh at the meteorological department if they start providing such a wide range of temperature forecast. Hence, you need to come up with an interval estimate, but that interval estimate should have a confidence level associated with it. For example, industry standard is 95%. What does that mean? 95% of the times the range that you provide and the true population value should lie within that range. Right? You'll come to know about this interpretation in a moment from now. This also means that there is a 5% chance that you might go wrong. That is absolutely fine. You cannot ever be 100% accurate with your predictions or forecasts. Always there will be some leeway that would be provided. And this 5% chance of you going wrong is represented using alpha. It's just given a notation alpha. If this is alpha, this is 1 minus alpha. In this 1 minus alpha is called as confidence level. This is the industry standard. If your management does not tell you anything around the confidence level, this is what you need to assume. Statisticians, mathematicians have done umpteen number of experiments in the past, and based on that, this is what they have come up with. However, if you're working with a nuclear power plant, would they give you a 5% chance of you going wrong? Absolutely no. They might say, hey, I would give you only 1% chance of you going wrong. That is given a notation alpha. That means 99% of the times you have to be accurate, which is given a notation 1 minus alpha. If you're working in a manufacturing plant, wherein you manufacture shirts, the chance of you going wrong might be slightly relaxed. People might say, hey, I want you to come up with a range of our sales for the next quarter. However, I want you to be 90% confident. That means there's a 10% chance that you might still go wrong. Right? Since probability associated with a single value is 0, you need to come up with an interval estimate or a range. But the range cannot be so wide. You need to come up with a range given confidence level. Hence, the interval that we come up with is called as confidence interval.